Hi guys, my camera's not working well today, so you're going to have Bitmoji me talking to you. We're going to go through lesson 3.5 and 6, which talks about sequences and proportional relationships. So like usual, we have some skills that we're working on today. The first one is writing arithmetic and geometric sequences recursively and with formulas. And we're going to construct linear and exponential functions, including arithmetic and geometric sequences. And we're going to recognize situations in which one quantity changes at a constant rate per unit interval relative to another. So our vocabulary then, the words we're working with today, the first term is sequence. A sequence is a series of numbers in a specific order. And you should be familiar with this from last year. You dealt with sequences and we turned sequences into equations. An arithmetic sequence is a numerical pattern that increases or decreases at a constant rate or value. The difference between successive terms of the sequence is constant. They can be written in the form a sub n equals a sub 1 plus n minus 1 times the quantity d. That d is the common difference, the difference between any two consecutive terms in an arithmetic sequence. Now, when we're talking about arithmetic sequences, we're talking about change in quantities that are adding or subtracting. When we get to geometric sequences, we can think about multiplication and division. But today is all about arithmetic sequences. So if we take a look at the example at the bottom here, I can see my sequence, this series of numbers, written out with a comma between each of them. And then I have this dot, dot, dot at the end. That tells me that the sequence continues indefinitely. My difference, so my change between each value, is a change of plus 2. So my difference is 2. In this one here, my change is that it goes down by 4, so my difference is a minus 4. Now we calculate that by taking one term and subtracting the one before it. So if I take 7 minus 5, I find that change of plus 2. If I take 21 minus 25, I find that change of minus 4. Last term here is proportional. So proportional means having a constant ratio to another quantity. And the reason that this is important today is that we are going to talk about proportional relationships where we have linear functions. So let's practice here. I have two sequences. I need to determine if they are arithmetic. Well, if I look at this first one here, I want to calculate the difference. So what is the difference? If I go from negative 8 to negative 4, well, that tells me that my change is plus 4. If I go from negative 4 to 0, well, again, I have a change of plus 4. And from 0 to 4, finally, I have a change of plus 4. So this tells me that yes, my final answer for this one is yes. The sequence is arithmetic because that change is constant. I'm adding 4 each time. Well, on the next one then, I'm going to do the same sort of process. I want to figure out the change from 1 to 1/2. Well, that's a change of minus 2. In our arithmetic sequences, our changes can only be addition or subtraction. Well, my next one, that change from 1/2 to 1/4 is a change of minus 1/4. So at this point here, I can already say, no, this is not an arithmetic sequence. The change is not constant. We'll do the last one just as a good practice here. From 1/4 to 1/8 is a change of minus 1/8. This one here is actually represented by the function 1 over r to the x, which is pretty cool, but we don't need to know about that right now. It's a geometric sequence. So now let's figure out how we can write an equation. And this is similar to what you did last year when you talked about start value and rate of change. But now we're going to use some more mathematical language. We're going to talk about the nth term of an arithmetic sequence. The way we write it is that sample equation that should have been in your notes. A sub n equals a sub 1 plus n minus 1 times d, times that difference. So if I take my example here, and this example you do not need to write in your notes. We're going to do another example on the next slide. If I have my sequence here, well, I can see that my change, the difference, is going to be a change of plus 3. So I'm going to start looking at those values there. I see my first term, my a sub 1, is the number 8. My second term, well, that was my first term plus the difference. So 8 plus 1 times 3. Then I have my third term. That's the first term plus 2 times the difference. My fourth term is the first term plus 3 times the difference. What that leads us to is that big idea that we wrote down, that the nth term will be the first term plus n minus 1 times the difference. This is a little bit different than the start value. The start value you talked about last year is really the 0th term. It would be a sub 0 is our start value. we'll keep going and we'll do an example. I think it'll make more sense. So now this is from your homework. This is page 193, number 18, and I want to write an equation for the nth term of the arithmetic sequence, and I want to find terms in the sequence. So the first thing I have here is the sequence -3, -8, -13, and -18. Well, when I'm looking at this here, I want to find the difference. I want to figure out what is the difference between each of these here. So I do that same process. If I go from -3 to a -8, well, that's a change of -5. So my difference is -5. I'm going to work with that original equation I have, that a sub n equals a sub 1 plus n minus 1 times the difference. Well, my a sub 1 value is the first term in my sequence. So I know that a sub n equals a sub 1 plus n minus 1 times my difference. Well, now I need to simplify my expression here. I've got some distributive property that I can do. And I find out that -3 plus, well, -5 times n is a -5n, plus -1 times -5 is a +5. Now when I combine that -3 and that +5, I'm combining my like terms, and I get a -5n plus 2. A sub n equals -5 plus 2. Well, now when I'm using this here, I wrote the equation, but I want to figure out what the 12th term is and which term is -83. So I'm going to rewrite my equation up here just so it's out of the way. A sub n equals -5n plus 2. I'll erase off this stuff here. There we go. I want to find the 12th term. Well, my 12th term, that's when n equals 12. So I'm going to take my equation, a sub 12. So the 12th term is going to equal -5 times 12 times my n value plus 2. I'm using this equation from right up here. When I combine, or when I simplify here, I get the 12th term is going to equal, well, -5 times 12 is -60 plus 2. So I find out that the 12th term is -58. And I could have gotten there. I could have kept writing. I had the first term, second term, third term, fourth term, fifth, sixth. Could have gone on. And eventually I would get the same answer. But it's a lot easier and simpler if I use my equation. Well, now I want to know which term is -83. So now I want to know a sub n is -83. And I want to know what's n. So I start with my equation. I have a sub n, which in this case I'm going to use 83, equals a sub 1, or no, sorry, equals that -5 times n plus 2. I'm going to use my equation solving skills. I take away 2 from both sides and I get -85 equals -5n. Divide both sides by -5 and I find out that the 17th term is -83. Your homework problem just asks you for the equation, but I wanted to show you how we could use the equation to find a given term or to use a term and find which place it would be in the sequence. One more practice problem from the homework here, and this is a problem that I found really interesting because when I first approached it, I didn't even know what I was doing. So what we're going to do here is we're going to look at, we're going to find the value of x that makes 8 plus x, 4x plus 6, and 3, the first 3 terms of an arithmetic sequence. You do not need to write this one in your notes, but it is a homework problem, so you may find it useful to follow along here. First thing I need to do is I need to make the difference between the terms the same. So what I'm doing, just like if I had the sequence 1, 3, 5, 7, I would find the difference between my terms. And I can tell, because I have a great math brain here, that the difference is going to be +2. But how I do that is I take the second or the third term minus the second term to find out that difference. So I'm going to do the same thing with these ones here. I'm going to take the second term minus the first term to find the difference. So I have 4x plus 6, 4x plus 6, minus my first term, That would be the difference. And I want to set that difference equal to the difference between the third term and the second term. So the third term minus the second term. Now all I need to do is I need to simplify. When I see that minus, that's really the same thing as plus a negative 1. And I'm going to use my distributive property. 4x plus 6 stays the same. There's nothing I need to change. There's nothing outside my parentheses. Plus a negative 1 times x plus a negative 1 times 8. On the other side, I'm going to do the same thing. That minus on the outside of my parentheses is the same thing as plus a negative 1 times each of those pieces. And I get 3x plus a negative 4x plus a negative 6. Combining like terms on each side, well, on the left-hand side, I get a 4x and a minus 1x. And a 6 plus a negative 8. 3x plus a negative 4x plus a negative 6. Now I need to start combining my terms on the opposite sides of the equals sign. So I'm going to add 1x to both sides. And I get 4x plus a negative 2 equals negative 6. Add 2 to both sides, and I get 4x equals a negative 4. My final answer, I get x equals negative 1. So what does that make my sequence? This is as far as your homework asks you to get, but if I then take it back, I'm going to plug into my sequence. I get negative 1 plus 8. My first term is going to be 7. My next term, well, I take 4 times x plus 6, and I get negative 4 plus 6. Well, that's 2. Hey, my 7 disappeared. And my third term in the sequence, I get 3x. Well, 3 times negative 1, well, that's a negative 3. So my sequence looks like 7, 2, negative 3. What is my change? Well, this tells me that my change, that difference, is a minus 5. Lots of cool things we can do with this. This practice problem throws in a whole bunch of different skills. Your homework just asks you to find that x equals negative 1. So now let's talk briefly about our proportional relationships. We're talking about proportional relationships in the form y equals kx, but now we may shift it. That's our parent, is y equals kx. But now we might have y equals kx or y equals mx plus b. We might shift it up or down so that it crosses the y-axis at a different spot. First one we have is a table here. So I need to use this table to figure out how to write my equation in function notation. Function notation tells me I'm going to be using that f of x equals something. Now last year you called this y equals mx plus b. This year we're going to do f of x equals mx plus b. Same thing. We have our output as a function here. With our output function, the first thing we need to do is we need to find that difference which tells us our slope. We always talk about change in y over change in x, our rise over run. So let's calculate our change in x and our change in y. Change in x, well, if I go from 1 to 2, that's a change of positive 1. My change in y, if I go from 3 to 2, that's a change of minus 1. So my slope, my m value, is going to be a negative 1, my change in y, over my change in x. When I simplify my fraction, negative 1 over 1 is negative 1. So I have f of x equals negative 1x plus b. Well, in this case here, I don't know yet what that b value is. I'm not sure what my y-intercept will be. I know from the last lesson, if I'm looking at a table, my y-intercept is the y value paired with an x value of 0. But I don't have an x value of 0 on this table, so I need to come up with a different way to find my value. What I'm going to do is I'm going to choose a point. In this one, I'm going to choose the point 3, 1. And I'm going to plug in the pieces that I know. I know that f of x, in this case, is 1. And that's going to equal negative 1 times my x value of 3 plus b. So I get 1 equals negative 3 plus b. I add 3 to both sides, and I find out that b equals 4. So I have my b value, I have my m value, I can write it into my equation, and I get f of x equals negative 1x plus 4. Final answer, function notation. Last practice problem for today is out of the homework. It's page 200, number 8. We're going to do the same sort of thing. We need to find our m value and our b value. Well, to find my m value, in this case, I'm going to use my slope triangle. When I'm looking at my slope triangle, I see that my change in y was a change of 1. My change in x is a change of 4. So my m, my slope, is going to equal my change in y over my change in x. For my b value, I need to find where I cross the y-axis. So in this case here, I cross the y-axis at a value of 2. My equation then is going to look like the function of x is equal to my slope times x plus my y, plus my y-intercept, which in this case is b. Too much erasing. Which is 2. F of x is 1/4 of x plus 2. Now you can go ahead and get started on the homework. Your homework task is page 193, number 7, and 9 through 33 multiples of 3, and then number 200, 1 through 8, and 13. On this assignment, just like on the last one, you can ignore the graphs. If it tells you, I think number 7, I know, asks you to graph. A few other ones might. You can ignore the graphs. So no graphing. When we get to chapter 4, we're going to be doing a lot of practice with graphing. So tonight, just do the functions, the equations, the number stuff. You can ignore the graphs. Thanks for all the hard work. We are going to take a quick quiz over this before we dive into chapter 4. See you later.